Hello friends, welcome to my channel. Let's have a look at problem 2270, number of ways to split array. In this video, we are going to share a solution based on the use of partial sums. So this problem actually is a follow-up problem or follow-up video for that of Leetcode 2256. So first, I'll read through the problem statement to digest the requirement, and then we do the analysis, and finally we share the code. First, the problem statement. We are given a zero-indexed integer array nums of length m. So nums contains a valid split at index I if the following two conditions are true. First, the sum of the first I plus 1 elements is greater than or equal to the sum of the last n minus I minus 1 elements. And secondly, there is at least one element to the right of index I. So because for a list, if zero indexed, the largest index is n minus 1. So we just need to consider up to index n minus 2, right? Based on this assumption. So we are required to return the number of valid splits in nums. So here are two examples. So in example 1, the output is 2. So notice that the length here is 4. So there are indices 0, 1, 2, 3. So we just need to consider indices 1, 0, 1, 2, right? So for this problem, as explained here, index 0 and index 1 are valid split points, and index 2 is not. So the output is 2. So similarly, we can interpret example 2 for the output. So before we do the analysis, let's look at the constraints. So first, the length of this list is bounded below by 2 and bounded above by 10 to the power 5. And the elements in the list are bounded in absolute by 10 to the power 5 by absolute value. So with that said, we are ready to do the analysis. So for this problem, so we actually can use prefix sum or suffix sum, and then to compute and compare the left hand sum and the right hand side sum at index. Notice that when we compute the left hand side sum, so the current index element is included, while we compute the right side, the current index element is not included. So for this problem, we could use both prefix sum and suffix sum, or we can use one of them together with the total sum. So as we have done two solutions formats for Leetcode 2256, so in this video we just need to do one version. So here I'm going to use the second choice. I'm going to use one of the prefix and suffix sum. Here I use prefix sum only, and then I'll take advantage of the total sum. So with that said, we are ready to do the coding. So first, I'm going to get the length of this nums list. So this n is the total number of elements in the list, and then we're going to use first get a sum, the sum of the nums. So this is the total sum. And next, so we are going to initialize a result variable. So this result variable is used to count how many valid splits in this problem. And then we are going to initialize our partial sum list and then set it up. So I'm going to use this because the first element in nums is also its own partial sum. And then we're going to iterate over the indices, and in between we're going to do the split point check and also set up the partial sum. So because of the second condition here, we just need to consider the index up to index n minus 2. So for this, let's use this for I in range n minus 2. N minus 1, because the this is not included, so the largest one is n minus 2. So notice that the length is larger than or equal to 2, so this n minus 1 is greater than or equal to 1. So with that said, so let's first consider a special case. So if I equals 0, right, then in this case the partial sum 0 is already, in other words, the non-zero element is already its own partial sum. So we just need to check the condition. If partial sums 0 or I is greater than or equal to the total sum minus this guy itself. So that is, let's copy this one. So like this. So this is the condition. So in order to make it shorter, so we can put this negative sign back. That is 2 times this guy, right? So let's say 2 times this guy. So if this is the case, so we're going to increment this result by 1. So this finishes the treatment for the index I equals 0. And otherwise, so we need to first determine the partial sum up to the current index. Partial sums I, so is is determined by the previous one added by the current number. So that's the partial sums I minus 1, right? So now because I is greater than or equal to 1, so I minus 1 is greater than or equal to 0. So then we check this condition again, right? So we can copy this one and then put it here. So with that said, that's about it for this problem logic. Then we are ready to return the final state of this result variable. So up to now, I guess we are ready to do the test. So let's first test a special case. So this passes example 2. Now let's look at the generic case. Yeah, it passes all the generic cases. I guess that's about it for this specific problem. So in this video, we shared the use of partial sums to solve this kind of problems. If you have time, you are very welcome to check out the video for Leetcode 2256. So with that said, that's it. Thank you.